Hello, class. This is Algebra 2 Spring Midterm Review video part B. I did the first part a while ago, and I totally forgot. I only got halfway through the quiz, or the thing. So this is the midterm, spring midterm, the second video. It says, graph the quadratic function and find the features listed below. Notice, this is in intercept form. Or factored form, depending upon what you want to call it. Okay? From this, you can get the x-intercepts. The x-intercepts, you just set each of these factors equal to 0. So what makes x plus 2 equal to 0? That's going to be negative 2. So I write the order pair negative 2, 0. What makes x minus 4 equal to 0? Well, that's going to be 4. So it's 4 comma 0. So we know the two x-intercepts. We know one x-intercept's at negative 2. The other one's at a positive 4. We also know, since the sign of this the leading coefficient, the sign of the number in front of the factors is negative, we know it's a sad graph. We know this graph has got to be going like that. So we got the two intercepts. We can find the vertex by finding the axis of symmetry, because the axis of symmetry is just the x value of the vertex. So that would be x equals just the average of negative 2 plus 4 divided by 2. That's 2 divided by 2, which equals 1. So we know that the axis of symmetry is x equals 1. That means we have this kind of dashed line right there that splits the parabola into halves. The vertex is simply going to be, let me increase the thickness. Okay, so the vertex is going to be at x equals 1, comma. Now we have to plug 1 in to our equation. Okay, so when we do that, we got 1 plus 2, which is, oh, golly, why does it keep doing that? I do not know these things. So that's 3 times 1 minus 4 is negative 3, and we're still multiplying by a negative 1/3. So that's negative 9 divided by, multiplied by negative 1/3, and that's 3. The vertex is at 1 comma 3. All right, so 1, 1, 2, 3. So there we go. We have 3 points. We can now graph a simple graph of this parabola. Okay, and there you go. All right. Trying to, use the counting method that you go over 1, square it, multiply it by a third, and go down a third. Go over 2, square it, that's 4/3. Go down 4/3, which is 1 1/3, which is, actually, that's a pretty good graph. I'm pretty impressed with myself. If I go over 3, 1, 2, 3, 3 squared is 9, multiplied by negative 1/3 is negative 3, and I would go down 1, 2, 3, and that puts me right where the x-intercepts are. So there you go. All right. And then write the equation in general form. Well, that means we're going to have to expand, multiply out the whole negative 1/3, parentheses, what is that, x plus 2, x minus 4. FOIL it, first, outer, inner, last, gives us negative 1/3, x times x, that's x times x is x squared, x times negative 4 is negative 4x, 2 times x is 2x, and 2 times a negative 4 is negative 8, or minus 8. All right, and then combining like terms, we have x squared, negative 4 plus 2x is negative 2x. and minus 8, all multiplied by the negative 1/3. So this comes out to be negative 1/3 x squared plus 2/3 x plus 8/3. Okay. So there you go. Now, it's kind of ugly. That's the standard form. Now let's moving on to question 12. It says, solve each equation by factoring. Well, to factor this, we're going to have to, I'm going to shrink this down because I don't give you guys much space. We have to get the equation equal to 0. So we're going to add 4 to both sides. And you get this. Now that it's a quadratic equal to 0, we're going to factor. Look for products on what multiplies to 24, adds up to 11, 8, and 3. So this is going to be b plus 8, b plus 3 equal to 0. That gives us negative 8 and negative 3. Those are two solutions. You could check it and multiply it together and see if it works out. It will. Okay. Then it says, oh, and then we got this one. Factor this. Well, first step, when you have a number other than 1 in front of the squared term, is you got to see if there's anything common between the numbers 14, 9, and 1, and there isn't. All right, there's nothing common between those three numbers. So now we look for product sums. Again, we look for two numbers that multiply to, in this case, 14, add up to 9. That's 2 and 7. Then we got to make a box. Okay. And we put the 14, what is that, a squared? And the 1 here. And then we have to fill in, we have a 7a and a 2a. Because these two have to add up to the 9a, that's the middle term. Now look for common terms here. And what's GCF? Let's GCF down the first column. We got 14a squared and 2a. 2 and a can come out. Okay. Now we GCF down this column. 7a and 1. Well, a 1 is the only thing that's common, so we can pull out the 1. Now we backtrack, right? We got 14a squared. What do you multiply 2a by to give us 14a squared? And that's going to be 7a. And you can check, what is 7a times 1? Indeed, it's 7a. Then, what do you have to multiply 2a by to give us 2a? And that's going to be 1, so that's a positive 1. And our last check would be to make sure that 1 times 1 gives you 1. So the factor version of this is now going to be 2a plus 1 times 7a plus 1 equals 0. Each one of these, 2a plus 1 equals 0, 2a equals negative 1, a equals negative 1/2. And this other one, you solve 7a plus 1 equal to 0. Subtract 1, 7a equals negative 1. Divided by 7, you get a equals negative 1/7. Those are the two solutions. Okay. Now, completing the square. First step, I got to blow this up because I shrunk this down, so I went, because this was created a long time ago with the thought that if I had to create worksheets, I wanted to conserve paper. So anyway, we're looking to complete the square. The first step is to move the constant over. So we get x squared plus 10x equals 39. Now comes the fun part. Now we're going to take half of the number in front of x. Half of 10 is 5. We're going to square it and add to both sides. The left side just turns into x plus the number inside the parentheses, which is 5 squared. And the right side is 39 plus 25. 30 plus 20 is 50. So 55 plus 9 is 64. So we end up with x plus 5 squared equals 64. So take the square root of both sides, you get x plus 5 on the left. On the right, you get plus or minus square root of 64, which we all know to be 8, plus or minus 8. And x equals negative 5 plus or minus 8, which is going to be negative 5 minus 8, which is equal to negative 13, and negative 5 plus 8, which equals 3. So we have negative 13 and 3 as our two solutions for that. All right? All right, question 15. We're supposed to complete the square on that ugly polynomial. They tell you it's a circle. So the easiest and the best way would be to rewrite this with the x's together. So that'll be x squared minus 12x. And then I'll do blue for the y. So then we'll have plus y squared plus 22y. All right? And then I had moved the positive 148 over to the right, by subtracting 148 from both sides. So we have this. Now, we take half of the number in front of x plus negative 6 squared, and we add it to both sides. And then likewise, we take half of the number in front of y, which is half of 22 is 11, square it and add to both sides. Okay? This left side is pretty straightforward. It turns into x minus 6 quantity squared. The blue piece turns into y plus 11 squared. And we just have to figure out what negative 148 plus 36, which is negative 6 squared, plus 121 is. So I'm using a calculator that you can't see. Negative 148 plus 36 plus 121 gives us 9. So we have this. And this is your equation of a circle that you can get the radius and the center from. So I want to move this down. I guess I don't have like a statement. There's the equation. So, and then the radius is simply r equals the square root of 9, which is 3. So the radius is 3. So the center is at 6, negative 11. And the circle has a radius of 3. All right? Pretty straightforward. Next question. Question 16. It says, find the discriminant of each quadratic equation, then state the number of solutions. Number and type, actually. So, this is all about the quadratic formula. The discriminant is simply b squared minus 4ac. It's the thing that's underneath the square root of the quadratic formula. Again, you'll have an equation sheet for the quiz. For the midterm. So the discriminant d is going to equal, well, b is negative 6, so we got to go negative 6 squared minus 4 times a negative 9 times a negative 1. This is b squared minus 4ac. So that works out to be 36 minus 36, which equals 0. So since the discriminant is 0, and that's the part of the quadratic formula that's added and subtracted, we're just left with one solution, one real solution. Okay? And there you go. Solve each equation with the quadratic formula. So In case you forgot what the quadratic formula is, it's for this equation, ax squared plus bx plus c equal to 0. Then x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So that's your quadratic formula. You notice the thing underneath the radical? The square root, this thing right here is called a discriminant. That's what we used on the previous, on this problem right here. This is just the d. That's underneath the square root, okay? So to solve an equation like this, notice it's equal to 0. So you can instantly use the quadratic formula where x, oh, that's going to disappear. That's going to be x equals the opposite of b, b's 8, plus or minus the square root of b squared, which is 8 squared, minus 4 times a is 5, times c is negative 85, all over 2 times 5. Okay? That equals negative 8 plus or minus the square root of 64, that's what 8 squared is, times a negative 4 times 5 is negative 20. Negative 20 times a negative 85 is a positive. 20 times 85 is 1,700. Okay, plus all over 10. Now 64 plus 1,700 is 1,764. All over 10. So we take the square root of 1,764. Oh my goodness. It comes out to be a perfect square. The square root of 1,764 is just 42, which is 6 times 7. 6, 7 shows up all the time in math. So we have this. So we have negative 8, either plus 42 over 10, or negative 8 minus 42 over 10. Negative 8 plus 42 is 34 over 10. And negative 8 minus 42 is negative 50 over 10, which equals 3.4, comma, negative 5. Okay. And there you go. Here's another quadratic formula question. Again, we use the quadratic formula. X equals the opposite of the b. B is 6, so it's negative 6 plus or minus the square root of 6 squared, because it's b squared, minus 4 times a, which is 3, times c, which is 7, all over 2a. So this is going to equal, it's all over 6, because 2 times 3 is 6. And then we have negative 6 plus or minus. Now we have 36. Let me just type it in. 6 squared minus 4 times 3 times 7. That works out to be a negative 48. And 48 is 6, 7. 6 times 7, I think. Right? No, 48 is not. 48 is not 6, 7. 48 is 6, 8. Sorry. And so it's imaginary because we have a square root of a negative. So it's negative 6 plus or minus I square root of 48 over 6. Now 48 can be thought of as 4 times 12 or 16 times 3. So if we can go further, you'll get full credit if you get this. You'll get extra credit if you get this. Notice I still have the imaginary part. Okay. Square root of 16 is 4, so that's plus minus 4i times the square root of 3 all over 6. Okay. You can keep going. You can go 4 goes into 6. Let's see, 2 goes into both. So you can factor a 2 out. Now, do you have to do this? Not necessarily. All over 3. So that's a completely simplified answer. This is a partially simplified answer. This is a non-simplified answer, all of which are correct at this stage. All right, and our last question. If 3 minus 2i is a solution to a quadratic, what is the other solution? It has to be the conjugate, because they always show up in pairs from the quadratic formula. So if 3 minus 2i is a solution, 3 plus 2i, which is the conjugate, is equal to a solution. All right, and there you go. I hope that made sense.